All right, today we're going to talk about measuring constructing angles. And an angle is a set of points consisting of two different rays that have the same endpoint. And we call this endpoint the vertex. The same vertex from back when we talked about polygons. And the rays, well, they make up the sides of the angle. So here we got our vertex, and here we got our sides. So when we name our angles, this angle here, we're going to call angle CAB. And the way we do that is we just follow the points. C to A to B. And we can see that our vertex is the middle because we always got to follow the letters C to A to B. Okay, and then we could also name it angle 1 because we can see that they very conveniently gave the angle a name for us. Our third option is to call it by the vertex. So we can name it angle A. However, we can do it only if there is only one angle from that vertex. So if I draw another line here, we'll call it W, and now I've got angle BAW. We can't call it just angle A because then we don't know which angle we're actually talking about. So we can use that only if there's only one angle. Okay, so that's the basic of an angle. Well, there's also regions involved with angles, and the region that contains points that's between the sides of the angle is the interior of the angle, and the region that contains all the points outside the angle is the exterior. So everything in here, out forever, is the interior of the angle. It is inside the angle. And then everything out here, the whole rest of this box, is the exterior of the angle. So everything outside the angle. And it's going to look something like that. So let's go through and look at naming the three different triangles shown in our diagram. Well, the first one, let's just do this little guy right here. And that's angle. Need a little angle sign, because remember, if we have 3 points, that also means plane. So we need to know what we're talking about. So it's angle V, U, W. W is in the middle, because that's the way we do it. The second one is going to be this little angle here. That's going to be angle WUT. Again, vertex in the middle. And our last one is going to be the big angle right here. Angle VUT. And I don't have to say it, but I will. The vertex is in the middle. All right, so now that we know what an angle is, let's look at how we use it. And we're going to talk about our protractor postulate. And earlier in the series, we talked about the ruler postulate. Well, a protractor is just a ruler for angles. All right, so the rays of the form, ray OA, which is here, can be matched 1 to 1 with real numbers from 0 to 180. So we are only going to look at this point angles from 0 to 180 degrees. And then the measure of angle AOB, let's get a different color, let's do orange, which is this angle here, can be written as MAOB, is equal to the measure of the absolute value of the difference between the real numbers matched with ray OA and ray OB on a protractor. So here it's at 0. The 0 is on the inside, so we're going to measure on the inside to 140 degrees. So we're going to put the ray on 0, and we're just going to measure either on the inside or on the outside going this way. We're not going to use both. It's either or. So we recall from our segments that we have segment AB, or if we write just AB, that's the length of AB. Well, angles, we have here angle AOB, that's the actual angle and all the points on it, the interior, the exterior. Or we have the measure of angle AOB, which is going to be the measure. How many degrees are there? So these are things, and these are numbers. The measure of AOB is a number. Well, now we've got angles, we know how to measure them, we know about the measure of them. So let's go ahead and classify them. Well, first one is an acute angle, and it has a measure of less than 90 degrees. The second one's a right angle, we know because we have the little box here. And it has a measure of exactly 90 degrees. Next one is obtuse. And an obtuse angle measures greater than 90 degrees and less than 180 degrees. So somewhere between 90 and 180, which I'm sure that most of you have heard of acute angles and right angles and obtuse angles, but we need to revisit our definitions of them because now we need to be exact on what we're talking about. And the last one is a line, except it's not a line because we're talking about angles, so it is a straight angle. And yes, I know it is a line. And a straight angle has a measure of exactly 180 degrees. So all lines have 180 degrees of measure on them in regard to the angles. And this will come up, and this will become important in some of our work that'll come up a little later. All right, so let's measure each angle. First we're going to measure is GHK. So we got G through H through K. So we're going to write the measure of angle GHK. It's a number, so it's equal. And it's halfway between 120 and 130. I know my protractor isn't all that readable, but it's halfway between 120 and 130. So it's 125 degrees. Angles are always measured in degrees. for our purposes, 125 degrees, which is greater than 90 but less than 180. So it is an obtuse angle. Angle JHL. Let's see, J to H to L. So the measure of angle JHL is exactly 90 degrees, so it is a right angle. We have angle LHK. So we got LHK right here. Well, this one they didn't start on 0 for us, so we got to do some adjusting. So let's see. So here we're at 90. Let's write that down. Here we're at 55. So 90 minus 55 is 35. So the measure of angle LHK is 35 degrees, and a 35-degree angle is less than 90 degrees, makes it an acute angle. Let's do a couple more, just for fun. Angle RQU, R to Q to U. And let's do this one in green. So the measure of angle RQU is going to be 130 degrees. That's greater than 90, but less than 180. So it is obtuse because it's asking us to find the measure and then classify. Angle TQU, TQ, and U. So the measure of angle TQU is going to be, well, we could do 130 minus 90. Pretty simple, right? And we already have that. So it's 40 degrees. 40 degrees is less than 90 degrees. So it is an acute angle. Then our last one we're going to look at is UQS, angle UQS. So angle U and Q and S. So the measure of angle UQS. Oh, we've got 130 still over for UQ. We're at 40 for Q. So 130 minus 40. So it is a 90-degree angle, which makes it a right angle. All right, so pause the video, write 3 names for this angle, start it back up and see how you did. All right, let's name this angle. So start with our little angle symbol, and we're going from P to Q to R, and we got P, Q, R. We can name it after just the vertex because there's only one angle coming off this vertex, so we're going to call it angle Q. Well, we can also go the other way, R to Q to P, because that gives us the same exact information as P to Q to R. R to Q to P covers all the same points, so it is legal to name it that way. Excellent. So I want you to pause the video and write 4 names for this particular angle. Work it out, and then start it up again and see how you did. All right, so let's do 4 names for this angle. So our first one is XYZ. Our second one, we're going to do the backwards thing and call it angle ZYX. Thirdly, there's only one angle coming off this vertex, so we can call it angle Y. And lastly, they very conveniently named it for us, so we can name it angle 1. And that is how we name our angles. All right, here for this one, I want you to pause the video, figure out which one of these 4 angles does not belong with the other 3 and why. We'll talk about why. So pause the video, do it, start it up and see how you did. All right, well, let's start by highlighting our angles here, and then we'll highlight them on our triangle. So angle CAB is right here. Then angle BAC, all right, we're still in the same spot. Angle 1, oh wait, right here's angle 1. And our last one is BAC, so that's got to come over here, has a different vertex. Which one's different? Angle BAC. Why? Because angle 1, angle BAC, and angle CAB are all the same angle. So BAC is different because it is quite literally a different angle. Okay, so let's talk about our next little thing, and that's congruent angles. And we know when we had congruent segments, they had the same length. Well, congruent angles have the same measure. So angle A and angle D are congruent, and we write that the same way. Angle DA and angle D is congruent to angle D, and the measure of angle A equals the measure of angle D. So let's look at an example and talk about it a little bit. So identify the congruent angles labeled in the quilt design. All right, so let's look at these little arcs. And these little arcs work similar to the lines that we have with segments. So we know if we have a segment here and a segment here, and we have these little dashes, we know that we have congruent segments. Well, here we have, well, those little dashes don't work so well for angles, so we use these arcs. And just like with the segments, 1 goes with 1, 2 goes with 2. So we can see which ones go together. Now we can also see up here on angle G, there's a lot of different angles coming off of G. So we cannot name it just angle G, because that vertex has a lot of angles coming off of it. So we need to use all 3 letters to name our angles. So let's start with the 1. So I got 1 down here. So that's angle ABC. and it's going to be congruent to angle HGF. Then we go to the 2's, and here we have ADC. Angle ADC is congruent to angle EFG. Ones go with ones, two goes with twos. All right, so angle ADC, which is this guy right here, is 140 degrees. What's the measure of EFG? EFG is right here. They both have two arcs, so they're congruent. So the measure of EFG equals 140 degrees, because that is the definition of congruence. We're going to stop there, pick up the rest of this section in the next video.